Hello, dear students. Welcome you all. In this lecture, I am going to discuss about the Stirling formula, right? Stirling formula, right? Right. Stirling formula is basically a mathematical formula that was given by James Stirling, right? This formula is used to calculate the value of uh, log of n factorial, right? It give an approximation of the value of the log of n factorial, and mathematically it is equal to according to Stirling formula n log of n minus n, right? So this is the formula given by James Stirling. Now I will see what is the how this formula is derived, what is the importance of this formula in statistical and thermal physics. So you know very well that when we deal with the probability, right? We have derived it in another lecture. P R n minus R, right? So this is equal to n factorial divided by r factorial into n minus r factorial into 1 upon 2 raised to power n. So you can see here that in this formula we have n factorial, right? So we have to calculate the value of n factorial, right? Now in thermodynamics or statistical physics, we know the value of the n is very, very large. It can be up to 10 raised to power 20. And we know very well that 1 cc cubic centimeter of a gas contain around 10 raised to power 20 gas molecules, right? So when n is such a large number, in that situation, it is totally impossible to calculate the value of n factorial, right? Even we are not able to calculate the value of n factorial when n becomes greater than 20. We have to take the help of various mathematical tools to do it by using a computer, right? Simulation package, right? So when n is such a large number, in all those situations, we need a formula. So that formula, this formula was given by James Stirling, right? So we will see how this formula is derived by James Stirling. We know I can write n factorial is equal to 1 into 2 into 3, so on, n minus 1 into n, right? So this is the value of a factorial. Let's take a log on both the sides, log of n factorial. Then obviously it becomes log of 1 plus log of 2 plus log of 3, so on, log of n minus 1 plus log of n. Here log is a natural logarithm, right? Base e, right? So now I can write it summation of I go from 1 to or I can say not I am taking here k. K go from 1 to n log of k, right? So this is what log of n factorial, right? So now log n factorial is equal to this value, right? So it means log n factorial is equal to the sum of the log of all these numbers, right? So to do it, let's take a Excel sheet where I have done it for understanding, right? So this is the uh, Excel table. Here I have taken the value of k 1 2 3 4 so on 20 up to 20. Then I have calculated the value of log k. Then I have plotted a graph between k versus log k. You can see various points when k is equal to 0, log 0, 1. So these are the different points. It is a value at 2, 3, so on. So this is the graph you can see here. Now I'm going to discuss this graph here. Right. Now look at this graph, right? This is the graph, right? Graph of K versus log K, right? So you can see here very clearly that the values of log K are shown here. This is 2, this is 3, sorry, this is 2, this is 1, similarly, this is 4, this is 5, this is 6, right? All these are the value of log K, right? Similarly, you will have this table, right? Now, if you look at this graph, right? So it is very clear from here that the value of log K, because here we are taking the summation, right? We know summation is applied on a discrete data, right? We are taking the value of K is equal to 1, 2, 3. So the corresponding value of log K are shown here. So the values are like this. 1, 2, 3, 4, 5, so on, right? So if I calculate this sum, right, then this sum will give me the area under these bar diagrams, right? The area under these bar diagrams. If I increase the value of K, right, it is very, large number, right? Then what will happen? This var size will go on reducing, right? The data will then in that case become continuous, right? I will then not take 0, 1, 2, but instead I will take all the possible values, right? From 0 to 1, 1 to 2. So these bars will come very, very close to each other. And in that case, I can say this graph will take this situation. Clear? Right. So in this situation, this graph will become like this. So I can say this graph is the approximation of this. In that situation, when K is a very, very large number, right? So when K is a very, very large number and this graph is nearly the approximation shown as this, solid line, right? This line, right? Sorry, this line, right? So in that situation, I can write log of n factorial is equal to integration 1 to n log of k dk, right? So I converted summation into integration. The difference, you know very well, summation is applied on discrete data, integration is applied on a continuous data, right? So in case when K is very large number, then I can replace this with this, because in that situation, this summation, earlier it was the area under these vars, but when it is a very large number, then this area will be nearly equal to the area under this graph, right? This line, right? So in that situation, this becomes now this, right? So now I can take further this integration. So this integration will become log of n factorial is equal to k log of k minus k 1 to n, right? This is the uh, integration of log k, right? Log k dk, right? K log k minus k, right? We know very well. Now we are going to put the value of it here. So it will become n log n minus n. So this is what is called as a Stirling formula, right? Log n factorial is equal to n log n minus n, right? here I have written this directly. So even you can do this, you know, simplification by putting the value of these limits. You will only get k means n log n minus n minus n minus then 1 log 1, right? Minus minus plus 1. So log 1 is 0. So you will get plus 1. But we can drop, as n is a very large number. So you can drop this one. So you will ultimately get this, right? So there is no need to worry about these limits. So we get this formula, and this formula is known as a Stirling formula, right? Right. Now, this formula is actually an approximation, right? As I have told you in this graph, this is actually an approximation, right? This approximation will become more and more accurate as the value of the n. This value of n will become large and large, right? For example, if you take n is equal to, I mean, 10, in that case, there will be a large error. This value and this value won't be exactly equal. But if you take n is equal to 100, then these values will become nearly equal, right? I mean, error will reduce. So when n is a very large number, in those situations, it is nearly equal to this, right? So this is all about the Stirling formula. In all the applications of this equation, we will make the use of this Stirling formula, right? So thank you very much.